Hey friends, Kirill Gavrylyuk is back once again, which can only mean that it's Azure Cosmos DB time. We're going to hear about integrated cache, serverless capacity, including serverless API for MongoDB accounts, and Azure Managed Instance for Apache Cassandra today on Azure Friday. Hey friends, I'm Scott Hanselman, and it's Azure Friday. I'm here with Kirill, and when Kirill comes, there's a lot of cool features because we're going to hear about what's new in Azure Cosmos DB. How are you, sir?
Oh, really well. Thank you so much for having me again. We just released a ton of stuff around build in Cosmos DB and would love to talk more about it.
Mm-hmm. Yeah, there's a ton of new features. Cosmos DB was one of the stars of Build this year. And as we did last time, you brought a parade of friends who are going to show some of these great new features and show live demos.
And so I always try to, instead of kind of bringing myself, actually bring people who do those features and build those features. And then there are a lot, and really kind of gets a voice from the first frontier. Exciting stuff. Seriously, we've done a lot of stuff to make Cosmos DB even leaner, more cost-effective, helping developers all the way from doing everything for free with small apps to only paying for what you use. Exciting lineup. And I think we're starting with an integrated cache. This was an idea where in many applications you have to do a lot of reads. And if you just do reads directly at the database, whole database doesn't know that you're doing them repetitively. So you're paying for each of those reads unnecessarily. You can add a cache to it, but now you're dealing with two SDKs, and all you were trying to do is save some money. Might as well ask the database to do it for you. And that's what we're doing.
Yeah, let's hear about that because I've got lots of interesting architectural questions because I can think of about 10 different ways to solve this problem. And you're going to tell me the best way that will also save me money.
Awesome.
All right, let's bring in our friend. Hello.
Hey, Scott.
Hey, Tim.
Hey, Kirill. Great to be here.
All right, Tim. So integrated cache, we're always thinking about RUs. Every time you do a query, you see your RU charges, you see your latency. I know that there's probably some internal caching at the engine of Cosmos, but from an application perspective, I usually just make an in-memory cache of myself, or I get Redis, and then I'm kind of moving from one place and putting in another place, and now I have two things to think about.
And that's exactly, Scott. That's exactly the pain point we're trying to solve here. Now, traditionally, if you had a database and you wanted to add on caching later, it's a great option for improving your database's performance, right? It's going to decrease costs. It's going to decrease latency. But like Kirill had mentioned earlier, it requires you to use a completely different SDK for your cache, right? You can't have your entire database now behind one API, behind one SDK. You're now going to have to manage an SDK for your cache, an SDK for your database, and then also handle, manually populating the cache and validating the cache, and just provisioning the cache and things like that.
Mm-hmm. Yeah, when I'm thinking about data from a business perspective, I might say I need this in real time, but nobody really needs anything in real time. Like real time could be, it's a minute old, or it could be 5 seconds old, or it could be 4 hours. And Cosmos doesn't know that, but if there's some way we could tell it, that would be really cool.
Yeah, absolutely. So what we'll do today is basically take an existing app, which I'm actually just going to go ahead and run now. And within our 5-10 minute episode today, basically go and optimize it to leverage the integrated cache. Now, our big pitch with the feature is that you can do caching without any significant code changes to your app. So what I have right here is probably the world's simplest Cosmos DB app. It just takes this query right here that basically searches a fictional data set for all items that contain the word socks, and just runs the query again and again and again. And we go and we print out the latency for the query and the RU charge. And when we stop running it, we'll see the average latency and the average RU charge for the 727 executions of that query. So this is just running the query with Cosmos DB as is, no caching, obviously leveraging things like indexes and our query engine, but this is without caching.
And when I buy Cosmos DB, when I use the service, I'm paying for not a number of RUs, an absolute number, but I'm paying for a number per second, right?
That's right. When you provision RUs or use serverless, it's basically RUs or per second currency. So each of these queries costs you 48.6 RUs. So in a sense, you could kind of translate this to dollars, right? Like it costs a specific dollar amount each time you run the query.
Right. So I can get 400 RUs a second or something like that on a really basic system. And I could say, yeah, that cost me 0.0001 cents. And in this case, it also cost me 37 milliseconds.
It did, right. There's the latency cost. And then, like you mentioned, you can really directly translate that into a monetary cost.
Okay, cool.
And with caching, we want to lower both of these, right? The idea is you pay once for query execution, and then subsequent executions are the same query will be free, right? They won't cost you any RUs, and they'll have a lower latency. So what I'm going to go ahead and do now is on my Cosmos DB account, go ahead and provision something called a dedicated gateway. So I'll toggle this to provision. And our dedicated gateway is basically something that's built into Cosmos DB. It's server-side compute that's going to both route your requests and cache your data. So the integrated cache is built into the dedicated gateway. You can pick from 3 different dedicated gateway sizes here. And in general, the dedicated gateway size you pick is going to be mainly influenced by how much data you want to cache. So here we have our smallest SKU, the D4 SKU, that has 16 GB of memory. So I'm just going to go ahead and pick that and just pick one instance now since we're just running a simple demo. And I'll go ahead and save that to basically go and provision the dedicated gateway. Typically takes about 5 to 10 minutes or so to provision a dedicated gateway. Since our whole episode today is about 5 to 10 minutes, I'm actually going to switch over to this Cosmos DB account here, where I went ahead and provisioned a dedicated gateway in advance of our call together. When you go and provision a dedicated gateway, once the provisioning is complete, you're going to get 2 new connection strings, basically, for your data that you can use for connecting to Cosmos DB through the dedicated gateway. Basically, I'll first show, I guess, a good diagram of how we're going to modify our app to use these new connection strings. And then after we explore conceptually, we'll actually dive into the code and make all the code changes that we need to do to leverage caching. So right now, our app uses something called direct mode in Cosmos DB, where it connects directly to our backend partitions. So if we run a query, if we ingest data, basically the app, the SDK on your app will go and talk to all the partitions, route requests, aggregate requests, and things like that. When we go and use our new connection string, we'll be connecting to the dedicated gateway with gateway mode. And on this dedicated gateway, we have the integrated cache. So the idea here is the dedicated gateway both routes your requests and caches data. And because it routes your requests, if a request can be served exclusively by the dedicated gateway using the integrated cache, we actually don't need to go and execute the query or execute that request using your backend RUs.
Interesting. So in distributed caching, there's read through and write through and cache aside. Which of what is used here?
Yeah. So for basically, you can cache point reads and queries. For point reads, we'll cache data as it's written, and we'll also cache it if you go and basically read it. So as you ingest data, it'll automatically be populated in the cache for point reads, and then if you have a cache miss, we'll basically go and cache that data right after you've unsuccessfully tried to read it from the cache. For queries, it's only as the read-through attribute. So if you run a query and it's not in the cache, following execution of that query, we'll go ahead and cache it so you can, for future use, it'll be available in the cache.
Cool. And read through, I think as folks may know, is like a really simple and clean way from a business coding perspective to just get perf. You're not going to have to really think about this too much as the client and the consumer. It's just going to get faster and better, isn't it?
Yeah, that's the idea. I mean, you don't have to worry about any custom code, any custom logic, invalidating the cache, populating the cache. It's all very turnkey once you go and provision it and just connect to it.
Cool.
So that's the next thing we'll do. We'll basically take this concept and now explore it through our super simple app that we wrote. So I'll go ahead and close this window. Now, the very first thing that we want to do is modify our Cosmos client down here. And the 2 things that we'll need to change is our connection string. It'll now need to use the dedicated gateway connection string. and our connection mode. Instead of using direct mode, we'll want to use gateway mode. So what I'll do is I'll go back to the portal and I'll grab that dedicated gateway connection string. I'll go back into my app and throw that connection string in place of my old one. And it's going to look super similar to my old connection string, but it's just slightly different. Your old connection string will still be valid. It'll still work. But if you wanted to leverage the integrated cache, you want to make sure you use your new connection string.
Interesting. So, for example, as maybe I work for a company that has a shopping cart and some properties, or some projects rather. Maybe the consumer will use the gateway and they'll see their cached version, but the administrative backend would go and do in direct mode.
Oh, absolutely. That type of scenario is very common. You might even do something like maybe a daily data ingestion or something like that. Like going back to your shopping example, maybe there's just a bulk ingest of data every day at midnight. That could continue to use direct mode for improved performance, or bulk ingesting data, right? You could use like our bulk API and things like that for that. But if you wanted to just do caching for the consumer facing portion of your app, you would just use the separate connection string for that.
Cool.
Next thing we'll do is switch our connection mode to gateway mode. So we were direct before, we'll switch to gateway. And right now with the code as is, we're now going to leverage the dedicated gateway. So I literally just changed 2 lines. It took me all of 30 seconds to make the changes. And just like that, now our code is going to leverage the dedicated gateway. Now there's one more thing we'll need to do if we wanted to utilize the cache. The cache right now is eventual consistency only. Down the road, we actually want to support session consistency as well. But right now, requests must have eventual consistency in order to hit the cache, right, and use our cache data. So here we've specified the consistency level for queries. It's session right now. I'm going to go ahead and switch to eventual consistency for the cache.
And for folks that are listening, like there's different consistency models, right? This is a distributed system, distributed computing, right? You're guaranteeing that the data will be correct, but you're doing it in a kind of an informal way. Like it'll eventually be correct, plus or minus a couple milliseconds.
That's exactly right. And it's important to highlight that your app, your business case, right, and your application should be okay with eventual consistency if you want to leverage caching. If you were, let's say, a bank and you wanted to store people's bank account balances and things like that. Like that is obviously not a use case for caching, nothing specific to Cosmos DB, the integrated cache, but scenarios that really require strong consistency are not really a great fit for caching.
Yeah, you definitely have to think about your scenario and think about what you're doing. When I used to work in products and stuff, we had something that had an inventory value over 100. We wouldn't worry about it. We'd have lots of caching. And then when inventory got down to like 10, 5, 4, 3, 2, 1, then it was like, well, we could get into an oversold condition. So we would literally turn caching off for items with really, really small amounts in inventory. Just all kinds of ways you can solve whatever problem that you have. But you got to think about it. I'm hearing you say you don't just turn this on and hope for the best.
Yeah, absolutely. Consistency is a really important concept to get right. So I guess one good thing to bring up, and I'm actually glad you brought up that, I guess, previous scenario that you'd use caching for. In a lot of cases, it's not like a Boolean thing. Like you might sometimes be okay with a certain level of eventual consistency, but you'd want to basically cap the maximum staleness of your data. Yeah. And for the integrated cache, we have a setting to do this. We won't actually cover it in detail today, but feel free to read our documentation to learn more about this. It's called the max integrated cache staleness. And basically it's configured at the request level. And for a request, it's going to be the maximum acceptable staleness, basically, that you have for that read. So if you set it to 5 minutes, we'll guarantee that the data for that query or for that point read, if we use the cache, it's not going to be more than 5 minutes old.
See, that's fantastic. And it's scenarios like that where, like, I described a scenario and some of the convoluted solutions that we had for it, and you all have thought about a solution that is now just, a checkbox in Azure or something like that, which is really cool.
Yeah. So super simple. So I guess we'll hit the fun part and go ahead and rerun the app now with caching. So in total, all I did was make 3 code changes. I mean, it took us about 5 minutes or so to go through and make the changes in our app to leverage the dedicated gateway and start caching. And now when I run the app, I'm getting these queries, I mean, quite literally for free. The latency's gone down. I'm running the same query again and again, but it's not costing me any RUs. So if you had an application that ran the same query many times, and of course, I mean, this one that I have here is a little bit of an extreme case. Like most applications don't just run one query hundreds of times, but many do repeat queries sometimes. And if your application does repeat queries and you're okay with the eventual consistency, the integrated cache could help you save a ton of money on your Cosmos DB costs because it will quite literally make queries from the RU perspective free.
Fantastic. I dig it. So people can check this out now. Is this in preview or is this available for folks to look at immediately?
Yeah, great point. It's in public preview right now. So if you, want to try it out, it's available for you to do so. Right now, it's available for SQL API only, but you can use it on any Cosmos DB account, whether it's a new or existing account.
Very cool. And as we saw, it's not going to affect what's already going on with the connection strings that you have. It's going to make a different connection string because it is a gateway. So that's certainly something that you could try out immediately today after this show and staging, and maybe put that on your application. Thanks so much for sharing that.
Absolutely.
All right, we'll bring Kirill back. That's pretty cool, man. You know, I like things that save me money and save me time, and you just did both right there. So nicely done, sir.
That has been pretty much our focus for the last year, as you may have noticed. And I'm really excited about this one. Again, this is not an application cache. It's not like, don't use Redis, use this. The caches exist there for a reason. This is a database cache to save you cost when you interact with Cosmos DB and your scenario fits a pattern. And majority do. Like if you look at retail, 90% are reads, right, in retail. And imagine how much money you can save by leveraging integrated caching for those scenarios. Lots of stuff. It's also it inherits all the capabilities of Cosmos DB, so you'll get global distribution, a lot of other cool stuff once this goes generally available, and of course it will be available for all APIs over time. We started with SQL API. For the next feature, we'll start with Mongo.
Very cool. And then one of the big things that everyone's been talking about is serverless as it relates to Cosmos. And next we're going to see Cosmos DB API for Mongo, which you know I'm a big fan of. But the serverless capacity for that is gone GA. Is that correct?
That's right. Serverless is now available, generally available for all APIs. Use it in production. It's fantastic way to only pay for what you use, literally. And not pay anything if you go for the weekend. Great for sudden bursting applications. And let's hear from the people who actually build it. Let's hear from Gahl.
Hey everyone, thanks for the intro.
All right, Gahl, you've got some shoes to fill. Let's show me some cool stuff here. This is great. So serverless capacity is GA.
Yeah, so we have provision and autoscale, and now we have serverless, which is now GA on all APIs, including the API from MongoDB. And this really came from the customer feedback where some customers wanted to pay only for the RUs that they actually use, because some of these applications were just left idle. And why pay for the database when you're actually using it?
Yep, I've got a scenario where I have a little tiny bit of kind of constant traffic, and then every once in a while I have like my quarterly reports. And in the past, really, really small Cosmos DBs had no problem handling that background process, but then I would burst and it would be like, well, I'm not ready for you. And serverless would solve that for me.
Yeah, and as a cloud native database, it's very easy for us to actually architect this where it makes sense for users and for us, where when your database is not being used, you don't actually have to pay for it, which is really cool.
Yeah.
In this example, I wanted to show how we can actually go and create an API for MongoDB serverless database.
Okay, so which API best suits your workload? Okay, all those choices.
Exactly. This highlights the new API forward kind of intro that we have, where you can find out which API is best for your workload, decide on which API you want, and then create an account with that API. So in this case, we use the API from MongoDB.
Cool.
So let me just go to the create button here. You just fill out all of the details that you want. So fill out mine here. Enter an account name. Select the region. And then the important part here is you have to select serverless, which will apply for your entire database account. We can keep the version 4.0. We support 3 different versions here. And press review and create. Then the create button. And this will take about a couple of minutes to deploy, but we can actually just go into an account that's already ready. We can see here in the new Insights tab, which shows you, very direct kind of metrics that apply to your API. We can see that this is a very good use case here with this app here for serverless, because there's bursts of workload and then a lot of time with empty space where nothing is actually being used in the database itself. So you're actually saving money because you're just paying for the RUs that you're actually using.
I like that.
Yeah. So just to sum up, for applications that require the database once in a while, for applications that are for development or to test workloads, serverless is a great option for you.
Yeah, absolutely. Like Kirill was saying, if you're gone on the weekend, you don't want to be paying for the weekend.
Exactly.
So that is GA now, which means that people who have been in preview are going to be switched automatically to GA, and folks that are watching right now and want this feature can sign up immediately today.
Yeah.
It's the where we're going with this is for any workload that has an average ratio, peak to average exceeding roughly 10 factor, you want to use serverless. Any workloads that you occasionally use, you want to use serverless. Any kind of dev tests setups that you have that you don't want to run over the weekend, you want to use serverless. But it's not just dev test. It's like lots of production apps that are very important, mission critical, but just have very burstable traffic. And serverless is great for that.
So is that the decision point? Is it that idea that I have burstable traffic? Because one could argue that everyone has burstable traffic. So what's the real decision point for me to decide if I want to go in production for serverless versus dedicated?
Pick your peak throughput, your average throughput, and divide one by the other. If the peak to average exceeds 10x, serverless is the best.
Got it. That 10x. So an order of magnitude is what you think of as being a real burst.
Yes.
But if you're just going 50%, 100%, 50%, you're just kind of like having this nice sine wave of doing stuff, that's one thing. But if it's Black Friday every few hours, that's a burstable situation.
Exactly. And like it's in the end, and that's the important part, that there is no as efficient difference, right? It's the same database. It's really just how do you want to pay for your database? And I don't want to pay when I don't use it. So use serverless. But if it's something that runs Walmart shopping cart, chances are it runs always, and it's a high traffic always. Then obviously your auto scale with provision throughput settings will be your best friend.
Very cool. So already here in this episode, we have seen saving money, turning RU numbers down to 0. Now we're learning about other ways to save money and time with these serverless instances. It's pretty cool. Pretty cool, sir.
It's also, I think it's the only serverless MongoDB database service right now, as far as I know, which is something cool to be said.
Yeah, Cosmos is offering all kinds of things that other people don't have. So what's our last and final cool feature that nobody else has?
Okay, so the next is we've been always looking for popular NoSQL APIs, right? And Apache Cassandra is a very popular NoSQL technology, and would love to bring Theo over to us to talk about managed instance for Apache Cassandra. This is kind of a way to help you bring your Cassandra workload as gradually as possible to Azure without making any changes to your application, without actually even moving necessarily. You can extend your existing Cassandra cluster to Azure Cosmos DB with managed instance for Apache Cassandra. Theo, take it away.
Hello, sir.
Hello.
So If I were on, if I were running my own open source, pure open source Apache Cassandra today, and I was doing it myself, would I roll it my own? I'd basically make a bunch of VMs and just kind of manage that whole thing myself. It sounds kind of like a hassle.
Yeah, it is a hassle, and what we found is that customers who are looking to have that hassle taken away, that they're kind of steps along the journey that they want to be able to take. So of course we think Cassandra API is great, and obviously it's fully managed and everything. But not every customer is ready to make that complete jump to a pure PaaS service. There's certain concepts like request units or the way we do replication and partitioning and so on. Maybe they're just not quite ready to make that jump straight away. And so having another step on the ladder, if you like, is appealing. And this is what we've come up with.
So I understand that, and hopefully folks that have watched the show before and have familiarized themselves with Cosmos DB understand is that there's the wire protocol, there's that API where like I talk Gremlin, I talk Apache, I talk Mongo, and then the backend store is Cosmos DB, and that's amazing. And it's basically a translation layer as you move down there, but running pure open source Apache Cassandra, has some benefits as well. And like you said, it's a step along the path. Yeah. So this is not dependent on that backend Cosmos DB. It is really Cassandra.
Yeah, no, yeah. To be completely clear, it's not dependent in any way at all on Cosmos DB. It's built by the Cosmos DB team. Obviously, we think we know something about distributed databases, but it's not in any way dependent on the Cosmos DB backend. It's pure open source Apache Cassandra, and we have some deployment and scaling and maintenance operations. And outside of that, it's the Cassandra that you know and love.
Interesting. It makes me think about the analogy that I've used in the past, where it's like, I'm interested in a vehicle. I could do a manual shift, I could do an automatic shift, or I could just get an Uber or a Lyft. And this seems like this is the automatic shift option right before I've decided whether I want to go for, a completely managed vehicle that I don't even think about the maintenance of.
Yeah, absolutely. That's a great analogy.
All right, fantastic. Let's see it.
Okay, so let me start with doing something really simple. So I'm going to create a cluster from the portal. First of all, I'm going to look for an Azure managed instance for Apache Cassandra. And there we go. And just hit create. All looking very familiar so far, so I'm just going to enter a cluster name. We only have one SKU right now. This is a public preview service, but we'll have plenty more SKUs in the future. I'm just going to go for, let's go for East US. I'm going to put in a password here. That's my default password for the cluster. I'm just going to go with the default 3 nodes for now. Mm-hmm. And then the only other thing I need to do is I have to choose a VNet or create a new VNet to deploy that into. So all managed Cassandra clusters are deployed, injected into VNet. So I'm just going to find my VNet that I created earlier here.
I'm just thinking about how easy this is compared to setting up my own from scratch.
Hopefully it's pretty easy.
Well, anytime that you've got some open source software that runs on a virtual machine, first you got to think about the virtual machine. You got to think about the networking, and here all of that's. I mean, you didn't think about any of that stuff other than like I picked that subnet, that virtual network, and it's handled. And while I'm talking, it's being deployed. I just find that amazing. I remember back in the day when the boss would say, "Can you go and deploy this?" and then they would just go home, and I would spend the weekend deploying, and that was the cloud, and now it's this, which is amazing.
Yeah, exactly. That's exactly the goal. We want to take away all of the painful stuff, the stuff that you don't really want to be bothered with away, and just keep it simple in terms of the application side of things.
All right. So this one is already deployed, right?
Yeah, I'm just going to go and find a resource that I've already deployed here. So this is a VNet that I created earlier, because that one's going to still deploy for a while, so I don't want to keep us waiting for too long. And what I'm going to do in here, inside this one here, so you can see here I've already got, how many nodes have we got here? We've got 5 nodes in this cluster. And so just by doing a simple CLI command here, I'm just going to scale this up to 7 nodes. This is not something that Cassandra does out of the box. You have to install software, and you have to go through a careful orchestration of making that node come up properly within your Cassandra ring. But we've automated this, so you can just do this with just one simple command. And then as that's running, it's going to create more nodes in the cluster.
Interesting. I know that the command line exists and I use it, but I've not seen a lot of people use it at the same time. You know, it's like some things it's easier to click and some things it's easier just to type the command. And I think it's cool the way you're using that. And then just getting refreshed, like you're doing a thing in the command line and you're watching it be reflected in the portal.
Yeah, exactly. Anything for a better demo.
Well, I think still that would be a useful thing for anyone to know how to do. It's a reminder to me that those things exist.
Yeah, so while that's scaling up, it should be probably done in a minute there. Again, I'm going to just cover something else here that we want to talk about. So really, which is really live migrations, which can be a big challenge for customers, especially if they've got really big on-premises workloads, let's say, and they want to try and move this into the cloud. If it wasn't difficult enough as it was adapting to completely managed service, then they have to move all of their data there. So what we suggest is that where possible, customers should just use Cassandra's native capability to migrate their data. And one of the cool things about managed instance is that it allows you to create a hybrid cluster. So what that means is you set up a cluster, you give it the cluster name that's identical to your existing, let's say, on-premises cluster. And as long as you have network connectivity and you install managed instances, certificates, and gossip certificates in your cluster, then you can configure a hybrid cluster, which means effectively the data center that you deploy in managed instance is an extension of your existing cluster. And then Cassandra will just do its thing. It will replicate data across your cluster, and it will be pretty seamless in that sense. So that's one of the cool features. But if you're not able to do that, if let's say the version of Cassandra that you're running is not conducive to that, or maybe it's too old or too far apart from the versions that we support, or maybe for other reasons hybrid clusters aren't allowed, there's this technique that Cassandra admins tend to use, which is referred to as using dual writes. So if you imagine a timeline like this, where you're writing to the old database and you wanted to do a live migration, obviously you'd start by migrating the schema first. You can do that in an offline fashion. At some point, then you would switch to your app writing data to both source and target. And obviously, you want to make sure that the writes to target and asynchronous if you want to keep performance in line as things are live running, especially if you have a big migration to do. And then at some point after that, you'll bulk migrate historic data, and then you'll probably have, at that point, everything should be in sync, and then you'll have a validation process, and then you should be ready to cut over. So what we've developed to make that a bit simple, and this is a completely open source tool that you can download and install, is what we call a dual write proxy. So what you do with this is you install this on all of the nodes in your cluster, and then that's running on a different port. And then all you need to do is change your application to point to that port, and the proxy will route all requests to your running cluster and then forward all of the writes that happen to your target cluster asynchronously. And you don't need to change anything in your application code to do that. And if you want to, you can even change the port that the proxy is running on to be the standard Cassandra port, and then you don't need to make any application changes. Of course, if you did that, you'd have to change the Cassandra port to be something else because it have to run on a different port.
Interesting. It's just like adding another person to the party line. You know, you're having a conversation between you and I, and then a third person just pops in and they'll just transcribe everything, and we'll make sure we have copies in 2 places. And I'll go from a 2-person call to a 3-person call, and then back down to a 2-person call, swapping out transparently.
Yeah, exactly. So it's like a middle layer, and it just should make everything easier on the app side. So what I have here, I'm just logged into a VM here. We had the world's simplest Cosmos DB app before. I think this is probably the world's simplest Cassandra app that I have here. All it's doing is just inserting some rows into a table. So I've just got a Cassandra shell. on the left here that's showing my source cluster that I want to migrate from. And I've got another shell open here that is connected to my managed instance cluster that I want to migrate to. So if I go back to my app here, let's just run it once. We can look at the config stuff here. It's just pretty standard. I'm running on the standard port. So let me just run this once. And we'll see what happens. It's a pretty simple app, and it should have inserted some data. If I go and query this guy here, I should see some data in here.
Got to hit enter again. I think it was in select mode.
Yep. Rookie error. But of course, if I go to my target cluster, there's nothing there. And at this point, if I was taking this kind of approach, which is pretty popular, of doing dual writes, of course, I'd have to be changing my app code. And if that's really complicated and it's in lots of different places, and especially if I want to make it asynchronous going to my target, that can be something that would put people off. So let me just zero out the data back in here. We'll start this again. If I go back to my app here, all I need to do, and by the way, I should say I've got a cluster running here already, and I've got the proxy installed on every node on that cluster. It's running on a different port on 29042. So if I go back to my app and just zero this out, go back to my config files, what do I need to do? Well, I just need to change the port number. That's it. And then if I run this app again, go back to my proxy, I should see some activity here. And there we go. It's making connections to both source and target. It's routing that data, those requests, I should say, to the source, and then it's routing the writes to the target as well. So if I go back here, I should find now I've got data in here. And I've got data, I should have, hopefully, if everything goes well, the data in my target table as well. And that's it. It's really as simple as that. Makes it very easy for taking this type of approach. If you've got lots of application code to change, you don't want to have the risks of doing that.
Very cool. Right into two places at once. The dual write proxy, a very clever way to do live migrations, and all open source, available on GitHub.
Yeah, completely open source, and obviously the service is still in preview, and the proxy is out there. So we welcome contributions. It's open source, so get out there and try it.
Brilliant stuff. Thank you, Theo. Appreciate that.
No problem.
All right, Kirill. We had a parade of awesome today. All kinds of things from and by the Cosmos DB team. We saw the integrated cache, saving money. We saw the serverless capacity, now GA for Mongo, which is going to be great, saving time, money, and shutting things down when they don't need to run. And then just now we see the Azure managed instance for Apache Cassandra. Nice place on the path towards maybe using the Cassandra managed API on Cosmos DB.
They're all about meeting developers where they are. If they don't want to pay money, you don't have to pay money. If you want to run Cassandra, not quite in this Uber mode, but in a automatic shift mode, as you well put it, that's where we are. And then the fact that you can now run Cassandra hybrid, where some of it runs on-premise, some of it runs on managed instance for Apache Cassandra, the fact that you can run it serverless using Cosmos DB Cassandra API, and all of these things can be connected together seamlessly for your application. That's a nirvana for Cassandra developer. This is a full spectrum, meeting you wherever you want to be.
Well, fantastic. Well, please do thank your friends and engineers for sharing these cool things. I always love it when you bring really awesome live demos. And hopefully we'll see you again soon on Azure Friday with some great new stuff with Azure Cosmos DB. And for folks that are watching, all of the links to everything that we talked about in the docs will be in the show notes. So be sure to check that out. All right. We're having all kinds of fun learning about Azure Cosmos DB and the great services and features today on Azure Friday.
Hey, thanks for watching this episode of Azure Friday. Now I need you to like it, comment on it, tell your friends, retweet it. Watch more Azure Friday.